So yesterday, as we learned the derivative of exponentials, every exponential, 1, 2, 3, 3 parts. The log derivatives have 3 parts as well. Okay, so they are, because exponential and logs are inverses of each other, they have connected derivatives. Those 3 parts in exponential, what connects the first, second, and third part together? How are they related? Multiplication, right? Like part 1 multiplied part 2 multiplied part 3. Because logs are inverses, they still have the same 3 parts, but what do you think the relationship's going to be? Division. You're exactly right, so you're already on top of it. Here we go. Every log has the following derivative. It's the same 3 parts. If you find a log, go ahead and put parentheses around your u, and you're trying to take the derivative of the log. Here are the 3 parts. Part number 1 is the u, but it's division. It's in the denominator. Part number 2 is the natural log again, but division. It's in the denominator. Part number 3 is the only part that's not in the denominator, because that's the chain rule, and the chain rule is always multiplication, no matter what kind of function you're working with. So part number 3 here is the chain rule part. So you've already learned exponential of the 3 different parts. Now you just need to know, okay, I'm doing logs, and it's the same 3 parts, they're just in different places. 2 of them are in the denominator, and then followed by the multiplication of chain rule. So let's apply that to ln u. Ln u should have a derivative that's 1 over, and then the 3 separate parts. So if we're working on ln u, the first part would be u itself. The second part would be ln e, because the natural log is of the base of e. And then the chain rule would be du based on dx. So that is our multiplication of the chain rule. That's it. Every log has the same derivative. You just are now you know how to do any derivative logs. We're just going to practice that in multiple situations today. So here's a basic one. So some of your homework will be like this. Just find the derivative. That's all you need to do. So you recognize that it's a log, that it's going to need 3 different parts. And you set that up. Okay, my derivative is going to start as a fraction. The parts of my fraction will be the parentheses 2x minus 1. The next part, number 2, will be the ln of 4. It's always the ln. It's never common log or base log of any other base. It's always ln of whatever the base was. And then we multiply by finishing up the chain rule applied to what's in the parentheses. In this case, the chain rule is 2. After that, your job is to simplify if possible. So the rest becomes algebra. So the numerator right now is 2. My denominator is 2x minus 1, but my ln of 4, we talked about this yesterday, can be 2 ln 2, because 4 is 2 squared. And so that is something you can simplify. Now, if it was ln 5, there's nothing you can do to ln 5, because ln 5 is not a perfect, is not a power value. Yeah.
Is that necessary?
Yes, because I can take that 2 and simplify it. Okay, I can reduce because this is a multiplication. So your final answer would simplify to 1, and then 2x minus 1 with just plain ln 2 on the end. So yes, you're going to want to simplify that, especially if you're looking for a multiple choice match. Yeah.
How can you do that again? The ln 4 2?
So there's this called the. So if you have any ln a to the b power, that can be rewritten. It is equivalent to b in front of ln a. That is a property. That's true. Okay, so you can take any. I can take, say, 125. 125 is 5 cubed. And so then the equivalent of that would be 3 in front of ln 5. Those are equal. You can do that with any number that can be written as a power. So just be, okay, I can do it with 4, 9, 16, 25, 36. I can do it with the cubic powers, or the powers of 3. I can do it with 8, 27, 64, 125, just anything that can be written as a power. But anything that can't be written as a power, you don't have to worry about that. Okay, here's another one. Here's the log, that's the base of 10, but it has the square root of rad 5x in it. Just be confident in your 3 parts, and then times your chain rule part. So it's going to always be 1 over. So this starts with 1 over rad 5x, because that is what's considered our u, or could otherwise be written in parentheses. Then would come the ln of the number 10. Now 10 can't be simplified because 10 is not a power of anything. Now comes the chain rule, which you have to apply to the rad of 5x. If you're thinking about the rad of 5x, you should probably think of it as not a radical, but what instead? A 1/2 power. Think of it that way so that you can do the right derivative. So that would be, okay, half around the quantity 5/2 with a new power. Don't forget the new power. That's something that sometimes gets dropped. But you want to remember that that new power is 1 less than the original power and multiplied by the number 5. So if I'm putting all of this together, the only thing that's in my numerator for starters is the number 5. Okay, that's this chain rule 5 here. My denominator is going to have a 2. Where does that 2 come from?
1/2.
The 1/2. Okay, my denominator is going to have the rad 5x. It's going to have the ln 10. But what else is it going to have in the denominator? Another rad 5x. Where's that coming from? It's coming from this one. That will be a second rad 5x. So now I have 2 quantity rad 5x's in the denominator. So the 2 of those together would be a plain 5x. Right? 1 rad 5x times a second rad 5x. The 2 of them multiplied together makes a single 5x. And then that can be reduced because I now have a whole 5 in the numerator and a whole 5 in the denominator. So as I make my final reducing, my answer in its final form is going to be 1 over 2 and the ln of 10. And the ln of 10 doesn't need to be simplified. Did you follow that okay, or did I go too fast? Maybe need to like back up. How'd you get that again? Okay. Okay, so you know that there's got to be some more stuff we can do. So then you'd be asked to expand it. Okay, now not only show me you know how to do the derivative, but show me you know how to do something with the derivative. So first, find the derivative of the natural log of the quantity x squared minus 3x. Then find the x coordinates where the function would have both horizontal and vertical tangents. So first, we want to start with f prime. Get that going first. So 1 over, and then all the quantities. So 1 would be over x squared minus 3x, and then Lenny, because this is a natural log. And then multiplied by the chain rule of 2x minus 3. So looking at all 3 parts, you want to say, well, what do I have in the numerator? And since Lenny is 1, that can simplify. So my numerator is 2x minus 3. My denominator is x squared minus 3x. You see if there's anything that's reducible in that. Can't reduce the 3's, even though they're both subtraction. That's not legal. Okay. I can't reduce the x's, again, because it's subtraction. So there's nothing I can do to reduce. That's as simple as it gets. So now once you have the derivative, you move on to, okay, how do I do something with that derivative? How do I find where the function would be horizontal? So this goes back to your last test, which goes back to your last quiz. When something is horizontal, what do you know is true? Go ahead, Aubrey.
Zero.
What's 0?
The y value is 0.
The y value of, yeah, you're so close. Something is 0. It has to do with this. The slope is 0. So if something is horizontal, the slope is 0. If the slope is 0, that means the derivative is 0. So I want to take the derivative and set it equal to 0. So 2x minus 3 over x squared minus 3x gets set equal to 0. And what's even better than setting it equal to 0? Setting it equal to what? 0 over 1. Because when I set it equal to 0 over 1, then I can cross multiply. So cross multiplying by 2x minus 3. And then cross multiplying the other direction, I simply get 0. So then I'm left with 2x minus 3 equals 0. In other words, the numerator equals 0. So x is equal to 3/2. So tell me again, what's happening at 3/2 on this function? The slope is 0, which means it has a horizontal tangent. So I have a horizontal tangent here. Horizontal tangent at x equals 3/2. But there's more to the question. The question wants to know, well, where would you have vertical tangents? So I got to start back over with my derivative. And if my tangent is going to be vertical, what kind of slope does that have? Infinite slope. How do you write infinite or undefined slope? 1 over 0. So we'll go back and we'll take our same slope, and this time we'll set it equal to 1 over 0, and we'll do a different kind of cross multiplication. This time we will get x squared minus 3x equals 0. And because it has a square, how many answers will there be? There should be 2. And we get these answers by factoring. We factor an x out of the quantity, which means x is equal to 0 and 3, which means that's where we have vertical tangents at both 0 and 3. So this is a crazy looking function. This is a logarithmic function that's going to be swiveling and swooping all over the place. And I'm going to have 2 places where the tangent is vertical, and I'm going to have 1 place where the tangent is horizontal. So it's going to be moving all over the place. Okay? All right. I think this might be the example. I'm not sure. Do you have the sentences in there? Like you have the same function, the 1 over ln of 1 over x, I think, on yours maybe? Okay, that's fine. I decided last night, I knew most of you had already downloaded it, but I wanted to change it to t so we could ask a couple follow-up questions, but it's the same. It's the same original function. So if we have a particle that's moving with its position as a logarithm function, 1 over t, we want to answer the questions, will it be moving towards or away at time 2? And will it be speeding up or slowing down at time equals 2? So we're going to need all of it. We're going to need position, and we're going to need velocity, and we're going to need acceleration. So we're going to take all those things. So let's start with, we've got position. Let's do velocity. Velocity is going to be the derivative of the logarithm function. So 1 over, and then put in your 3 parts. So what goes in that first set of parentheses? 1 over t. The second part will be Lenny. The third part will be the derivative of 1 over t. But you might want to think about that differently before you take the derivative. You can think about that as t to what power? Yeah, you could think of it as t to negative 1. Those are the same thing. So you could either apply, what rule would you apply if you left it 1 over t? Quotient rule, 1 over, and that would be fine. What rule would you apply if you changed it to t to the negative 1? Power rule, and that would be fine. It's up to you how you want to do that. I'm going to leave it as the quotient rule. I'm going to say this is t times 0 minus 1 times 1 over t squared. I did the quotient rule. So altogether, for the velocity, since t times 0 is 0, I end up with a negative 1 on the top. Lenny is also 1, and I end up with 1 over t on the bottom. What do we do with a function? Oh, and sorry, and I forgot my t squared. And my, let me move that over. Okay, t squared. That can be simplified. 1 over t in the denominator times t squared in the denominator can be negative 1 over t. Okay, that's my velocity. Then I want acceleration, which is going to be another derivative. I think I'm going to use quotient rule again. You don't have to, but I'm going to use quotient rule. So that'll be t times 0 again, minus negative 1 times 1 over t squared. So that gives me positive 1 over t squared. Now I want to figure out, by plugging in the number 2, if those things are positive or negative. I don't need a decimal value. I don't need you to figure out exactly. I just need to know, is it going to be positive or negative? So we're going to compare those 3 things. We're going to figure out what's f of 2, what is v of 2, and what's a of 2. So if I plug 2 back into the original function, which was ln, I'll have ln of half. Do you guys know if ln of half is bigger, is positive number or a negative number without checking your calculator? It'd be something that I would hope you would know without having to check your calculator. Okay, why do you think?
Because it's negative.
This is not, because I'm not plugging a negative number in?
Is it negative because it starts with negative?
Do you remember what natural log looks like? Where does it cross? At 1. If it crosses at 1, that means anything bigger than 1 is positive, but anything less than 1 is negative. So this number is negative, okay, less than 0. What about velocity? If I plug in 2 into the velocity, and the velocity was negative 1 over t, what will I get? Negative for sure. That was easy. All right, what does it mean if both of them, both the position and the velocity, are negative? Does that mean I am moving towards or away from the origin? It means I am moving away. When both of them are negative, it starts out on the left side of the origin, and it's getting pulled farther towards the left with the negative velocity. Then I want to check the acceleration based on 2. So I check acceleration, and I put that into 1 over t squared. What is that going to give me? Going to give me a positive number. And so now I compare the velocity to the acceleration, and those 2 things have different signs. So what does that mean my particle is doing? Okay, and so it's slowing down. I just want to keep those types of questions in your mind. because they're going to keep showing up. So good thing to add into your notes for an open note quiz.
So we don't get these notes, we make our own notes?
No, you can use these.
Can we use like any notes on notability?
Any notes in Notability. All right, last one. Find the normal line to a logarithmic function at 0. So you guys are getting really good at these. We want the point first. Our point is going to be 0f of 0. So 0 times the natural log of 0 plus 4 plus e to the 0. What's 0 plus 4 plus e to the 0? 5. So this will be ln 5. Then I want to find my derivative. Because this is a logarithm, my derivative will have the different 3 parts. My first part will be x plus 4 plus e to the negative 3x. My second part will be linear. And my third part is going to be the derivative of the parentheses. So term by term, what's the first part of the derivative? Derivative of x is 1 plus the derivative of 4 is 0. The derivative of e to the negative 3x is 3 more parts, right? So 3 more parts, e to the negative 3x times linear times what? Negative 3. So altogether, my numerator becomes 1. And then remember that linear is 1. So 1 minus 3e to the negative 3x. My other linear is 1. So over x plus 4 plus e to the negative 3x. It looks bad, but all I'm asking to do is plug 0 into that. So we're going to plug 0 into all those places. So my slope would become 1 minus 3e to the 0 over 0 plus 4 plus another e to the 0. In other words, 1 minus 3 over 4 plus 1. Negative 2 over 5. So that would be my slope if I was asked for a tangent line. When you're asked for a normal line, then your slope will be y minus ln 5 equals the positive 5/2 slope of x minus 0.